All right, welcome back. In this video, we're going to be reviewing Chapter 5, our finance chapter. I'm going to be going over some of the more common questions that I'm asked in this unit. I'll probably use this video in future semesters, so if the question numbers don't line up, don't worry about that. I always add new questions, remove questions, and change questions, but hopefully this will still be helpful. So let's get started with the first one. All right, so to purchase a car, Sarah took out a 60-month loan for $30,200 with a 6.4% annual interest rate. Then after making 46 payments, Sarah receives a bonus from work and plans to use it to pay off the remaining balance. We want to calculate Sarah's monthly payment and the amount needed to pay off her loan. So first, calculating the monthly payment is the same as any of the other loan amortization problems that we've dealt with. So as a reminder, loan amortization is when we find the payment that will pay off the loan in an exact number of payments, in this case 60. So we'll grab our calculator. We'll go to Apps, and then Finance, and then Tvm Solver. So her car has a 60-month loan. So remember, N is the number of payments, which is also the number of times interest is compounded. So we could here find out that 60 months is 5 years, and then take 5 times 12 to get that there are 60 payments. But we really don't need to do that because we were already told that it's 60 months, which means there's 60 payments. So be careful in these questions. There's going to be one here in just a little bit where this is important as well, where it just gives us the number of payments rather than the number of years. So be really careful when you're working these problems. All right, then we want the interest rate. That was 6.4%. We want the present value. So that's going to be the amount of the loan, in this case $30,200. If Sarah had put a down payment on the car, so it tells us that the loan amount is $30,200. So maybe the car cost more and she put down a down payment. We don't know. Remember that all that matters for the present value is the loan amount. It doesn't matter how much the car cost. So maybe the car was $35,000 and Sarah put down $4,800 as a down payment. Regardless, again, only the loan amount matters for the present value. All right, payment is what we're looking for. Future value is 0, so anytime we're trying to amortize a loan, our future value is going to be 0. The payments per year, compounds per year, both monthly because she's got monthly payments, so monthly compounding as well. It doesn't say anything about payments being made at the beginning of the period, so we'll assume it's end, and then we'll go solve for our payment. So alpha and enter. So we get that the payment is $589.48. So $589.48. All right, so that is our monthly payment. That's the monthly payment that Sarah is going to make. Well, she would make it 60 times if she wanted to pay off the loan by just making that monthly payment. But she wants to pay it off after making 46 payments instead. So what we can't do here is we can't just multiply that $589.48 payment times 46 to see how much she's paid and then just subtract that from the $30,200. And the reason why is because this $589.48, part of that money goes to the bank every month. So Sarah makes that payment, and the bank takes their cut out of that, and only what's left over goes to paying off the loan. So by multiplying that by 46, that would be saying that every penny of that payment goes to paying off her loan, which is not the way it works. So thankfully, we can do this in the Tvm Solver really easily. So the way this works in the Tvm Solver with amortizing loans, the present value is how much you owe within payments left. So when Sarah has 60 payments left, she owes $30,200. So if we change in, it changes the number of payments remaining and changes how much she owes. So if we wanted to see how much does she owe after one payment, we could make that 59, and we could go down and solve for the present value. And we could see that she would owe $29,771.58 after making one payment. So we can just change into the number of payments remaining to solve for this. So in our problem, Sarah has made 46 payments. Now it's a 60-month loan, so that means she has 14 payments remaining. So that's one of the questions that we wanted to answer. And then we want to know the amount as well. So I just got that 14 by taking 60 minus 46. So she's got 14 payments remaining. So all we have to do to solve for this is we'll go up to n and change that to 14 for the 14 payments she has left. And then we change the present value. So notice we left the payment the same. And so we'll just solve for the present value here. And so we get $7,931.85. So $7,931.85. So that is how much money Sarah would owe after making 46 payments. And so if she paid that amount of money, that was 7,931. Oh yeah, that's right. 7,931.85. So if she wanted to pay it all off after making 46 payments, that's the amount she would need to make with 14 payments left. All right, so just 2 steps to that problem. Find your monthly payment. So we needed that. We needed the monthly payment to be able to then solve for the new present value. And then we could find the new present value within payments remaining. So those are the 2 steps to that problem. All right, let's look at the next problem. All right, so we've got a student takes out a loan of $1,200 at the beginning of each semester for 13 semesters to pay for college. The loan charges 7.4% interest, compounded semi-annually. The student graduates after 13 semesters and refinances the loan to a lower 6.7% rate, compounded monthly with monthly payments. Those are going to be made at the end of each month for 120 months. So we want to find the monthly payment and the total interest paid. All right, so this is a 2-part problem. So first of all, we need to figure out how much the student is going to owe at graduation. So this part's a little confusing because it's a little different than how we've typically done loans. So let's start off by resetting our Tvm Solver. So we'll put zeros in for the first 5 of these. And as a reminder, I would also always make sure to set your payment back to end if you ever change it to begin. All right, so they're taking out a loan of $1,200 at the beginning of each semester. Now, we're not trying to find out the payment necessary to pay off a loan. Not yet. That's the second part of the problem. So we're not amortizing a loan, which means all of these settings that we usually deal with loans are going to be a little bit different. So the present value is not going to be the loan amount yet. The future value is not going to be 0 yet. Those are all going to be true for the second part of the problem. What we're just trying to figure out now is if you take out a loan of $1,200 at the beginning of each semester, how much are you going to owe after 13 semesters? All right, so let's go up to n. All right, so n is going to be the number of payments. In this case, the payment is the amount of money taken in each semester. So remember, if something's done more than once, that's a payment. So this is the bank or some sort of financial institution is loaning this student money every semester. So that's a regularly occurring deposit. They're giving the student the money. And then the student gives the money to the college, but that part's not important. So that's going to be a payment, and that's going to happen 13 times. So 13 is 6.5 years with 2 semesters per year, but none of that is important. All that's important is there are going to be 13 payments of $1,200 made to the student. So again, we don't need to convert this to years. That's not important here. What's important is how many payments of $1,200 the student is given, and that's 13. All right, so the interest rate while the student is in college is 7.4%. The present value, so a typical mistake here is to put the $1,200 in the present value, which is which is not the case. That would be a one-time loan amount, which is not what we have here. Instead, the $1,200 is going to go in the payment. And so that's going to be $1,200. That's going to be a positive because the student is taking out a loan. So that is a positive amount of money going to the student. And then let's go down payments per year, compounds per year. So interest is compounded semi-annually, and the student is getting the money at the beginning of each semester. So that's 2 payments per year and also 2 compounds per year. Now it does say the $1,200 is taken out at the beginning of each semester. So we need to change the payment to begin because you need to pay for school at the beginning of the semester rather than at the end of the semester. So what we're trying to find here is the future value. Again, the present value would be if the student owed money before this started. So we're assuming the student owes nothing and then starts taking out $1,200 loans every semester for 13 semesters. So what we want to solve for here is the future value. That is, how much will the student owe at graduation? So remember, present value and future value are named for what they are. Present value is something in the present. Future value is something in the future. So graduation is in the future for this student. So we want to solve for that. So alpha, enter. So the student is going to owe $20,303.99. So $2303.99. All right, so we'll just write that down for now. So that's how much the student is going to owe at graduation. Now, at graduation, that's when we want to find the payment to amortize the loan. So let's go ahead and reset our calculator because now we need to do another calculation. So we'll put in zeros for each of the first 5 fields. And then we're also going to change the payment back to end because that'll be our default again. All right. So now the student refinances the loan for 6.7%. They're going to make payments for 120 months. So N is going to be 120. Our interest rate on the refinanced loan is 6.7. The present value, that's how much the student owes right now. So that is, we'll put that in as a positive amount because that's a loan amount. That's the amount the student owes. So $20,303.99. We're trying to find out the payment that will pay off this loan. Our future value is going to be 0 because we're trying to pay off the loan. And then payments per year, compounds per year, both 12 because the student is making monthly payments. It does also specify, if I move the calculator, we can see the payments are made at the end of the month. So we want to leave our payment at end. All right, so now we'll solve for the payment. And we get $232.62. So $232.62. So that's the monthly payment needed to amortize the loan or to pay off the loan in exactly 120 months. All right, total amount of interest paid. That's the next part we want to find out. So remember, interest paid is just the difference between how much the bank gave you and how much you give back to the bank. And so that is the same no matter what the scenario is, whether it's an investment, whether it's a loan, whether it's whatever, it doesn't matter. So we want to first figure out how much did the bank give this student. Well, we don't need our Tvm solver to solve for any of this. The bank gave this student $1,200 per semester, so that's 2 times a year for 13 years. But again, that's not really important. Really, they just gave it to him 13 times. So there's really no point in doing. We could have done times 2 times 6.5 because it's 6.5 years. But again, we already know that it's 13 semesters, so no need to do the conversion. So the student took out a loan of $1,200 13 times. So that's $15,600. Then the student paid back to the bank $232.62. and they made that payment 120 times. So times 120. So that's $27,914.40. And so if we take that and we subtract out the $15,600 that the bank gave to the student in the first place, we get that the amount of interest is $12,314.40. So $12,314.40. And so that would be the total amount of interest paid over those over the entire time period, which is the 13 semesters plus the 120 months. All right, let's look at the next one. All right, so we have a man deposits $17,000 at the beginning of each year for 14 years in an account paying 5% compounded annually. He then puts the total amount on deposit in another account paying 9% compounded semi-annually for another 13 years. Find the final amount on deposit after the entire 27-year period. All right, so this is very similar to the last problem. This is a two-part problem. So basically, anytime you're doing something in two parts, anytime where you are investing money in one way and then shift it, or anytime you're saving up money and then spending it, or anything that involves two parts, we're going to have to use the Tvm Solver twice. All right, so to do that here, the first thing we need to figure out is how much he'll have on deposit at the end of the first 14-year period. And then we'll use that to figure out how much he's going to have at the end of the second 13-year period. All right, so we'll grab our calculator. We'll do apps and then finance, Tvm Solver. Let's go ahead and clear out our calculator from the last problem. So we'll enter 0 for the first 5 fields. Make sure our payment is on end. Whoops, missed the interest rate. 0. All right. So he's depositing $17,000 at the beginning of each year, and it's compounded annually. So he's going to be making in total 14 deposits because he's depositing the money at the beginning of each year for 14 years. So once per year, that's 14 years. Interest rate, that is 5%. Present value, it doesn't say he's starting off with any amount of money, so we'll skip that. Payment is $17,000, so that's negative because he's putting that money in the bank. So that's an investment. Still his money, but he is loaning it to the bank. Future value, that's what we're going to solve for. Payments per year, compounds per year, both 1. Interest is compounded annually, and he's making 1 payment per year. And then it says he's depositing that at the beginning of each year. So we'll change our payment to begin. All right, so then we'll solve for our future value and get that at the end of that 14 years, he would have $349,835 and about 58 cents. So now we're going to start over with that as the starting balance for the next 13 years. So we'll go up here. So that amount, we'll go ahead and put that into our present value. It's going to be negative because he is taking that amount of money out. So that's why it's positive for our future value here. And then he's putting it into another account. So that's negative when it goes back into that account. So negative $349,835.58. All right, let's see. So our N is now, let's see, I think it said compounded semi-annually. Yeah, semi-annually for 13 years. So N is going to be 13 times 2, or 26. So interest is going to be compounded 26 times. Let's see, it's now at 9% interest. So interest rate 9%. There's no payment anymore. So he's just putting that whole amount on deposit, and then he's just leaving it there. So it doesn't say he's making any payments or changing his payments. It doesn't say anything about a payment during those 13 years. So we'll put that to 0. All right, then our future value, that's what we're solving for. Our payments per year and compounds per year, it's semi-annual. So now those are 2. And then since payments aren't being made, it actually doesn't matter what we put this setting at. So we could leave it at begin or we could put it at end. It really does not matter. That only matters if we have a non-zero value in the payment. So let's solve for the future value. And what we get is $1,098,721.26. So that's how much this man would have on deposit after the entire 27-year period. So again, it's because he was depositing with payments during the first 14 years and then without payments at a different rate for the second 13 years. That's why we had to break this problem into two pieces and use the Tvm solver twice. All right, let's jump to the next one. All right, so large semi-trailer trucks cost $105,000 each. A trucking company buys such a truck and agrees to pay for it by a loan that will be amortized with 8 semi-annual payments at 17% compounded semi-annually. So we want to complete the amortization schedule for the first 4 payments of the loan. We'll do the first couple, but we won't do all 4 because once you get the pattern, it's pretty easy. But getting the pattern is the tricky part. All right, so the first thing we want to do is just find out what that payment is. So our amortization payment, we'll do that the same way we would do any other loan. All right, so let's zero out our calculator and make sure our payment's set at end. All right, so in here, again, is always the number of payments. And so what we see here is it says that the loan is going to be amortized with 8 semi-annual payments. Now, that doesn't say 8 years of semi-annual payments. Those are two very different things. 8 years of semi-annual payments is 16 total payments over 8 years. 8 semi-annual payments is 4 years worth of payments. But again, number of years here is not important. All we need to know is that it is 8 payments. So that's our N. So we could convert it to years, which is 4, and then multiply it by 2 to get 8. But again, if we just know the number of payments, that's what goes into N. We don't have to convert anything. All right, interest rate 17%. Present value, that's going to be the amount of the loan. There's no down payment mentioned here. So the entire loan amount or the entire purchase price of the truck is the loan amount, $105,000. Payment's what we're looking for. Future value is 0 because we're looking for the payment that pays off the loan. Payments per year, compounds per year are both 2 because it is interest is compounded semi-annually and there's semi-annual payments. It doesn't say anything about payments being made at the beginning of the period, so we'll leave the payment at end. All right, so let's solve for the payment. So alpha enter. So the payment, $18,619.72. All right, so $18,619.72. All right, so that is the payment that this trucking company would be making for 8 payments. So what we want to do now is we want to figure out how much of each of those payments is interest. So that is, how much is the bank going to take out of each of those payments? And that is just simple interest. So not complicated. We are just finding the amount of interest that would be charged for one payment. And one payment represents a certain portion of a year. We'll talk about that here in just a second. So remember, interest, simple interest is I equals PRT. So to find our simple interest here, the principal is the amount on balance. So in this case, that is the full $105,000. Has nothing to do with the payment. Simple interest has nothing to do with how much that payment is. So the principal is $105,000. The rate, 17%, so 0.17, and then times time. All right, so this isn't the time for the entire loan. We're only looking for interest for payment number 1. So how much time is represented by payment number 1? So first payment is made for the first half of the year. Second payment is made for the second half of the year. So each payment represents half a year's worth of interest. So T is 1/2 for half a year. So if we were making payments monthly, that would be 1/12. If we were making payments weekly, that would be 1/52. So whatever it is, it's just one out of however many parts there are per year. In this case, 2, because semi-annual payments. All right, so we're going to take that. So we don't need our TVM solver anymore. We're done with that. So $105,000 times 0.17 times 1/2, or 0.5. So that's the interest payment, $8,925. All right, so that is the amount of money that the bank would take out of each payment, or out of the first payment at least. So when the trucking company pays $18,619, $8,900, almost $9,000 of that goes right to the bank. It doesn't go to paying down the loan. So the amount applied to principal, that's the amount that goes to paying down the loan. And to get that, we just subtract these two numbers. So the amount that the trucking company paid to the bank minus the amount that the bank took out. That's how banks make money from loans. They charge interest. So $18,619.72 minus $8,925, and that gives us $9,694.72. All right, so that is the amount that is applied to the principal. So after the trucking company makes that payment of $18,600, only $9,694.72 of it is left over to pay down the balance. So now we're going to take our balance, $105,000, and subtract out that amount, the amount that's applied to the balance. So minus, and then we can just hit second and the negative button to pull up that answer. And so we get $95,305.28. So $95,305.28. So that's the new balance. All right, so then payment number 2, which after you enter that information, it'll pull up payment number 2. The payment amount, still $18,619.72. An amortized payment tells you the same amount you would pay every single month. The interest payment, however, is not going to stay the same because the amount owed is no longer the same. So interest here is going to be based on the amount owed, $95,305.28 times 0.17 times time. Now, just because this is payment number 2 doesn't mean the 1/2 changes to 2 halves or 1. It's still half a year's worth of interest. So essentially, we're just applying the 17% interest in 2 parts. So half of the 17% interest is applied to the first payment because that's half a year. And then the other half of the 17% interest is applied for the second half of the year. All right, so we take that $95,305.28 times 0.17 times 1/2 for 0.5. And so that's going to be our interest for the second payment, $8,100.95. All right. And so from there, you're just going to continue this pattern. So we'll subtract those 2 numbers. That's going to give you the applied to principal. You'll then take that number and subtract it out of the $95,305.28. That'll give you the new balance. And then we just kind of repeat that process for as many times as it asks for it. So that's how you calculate an amortization schedule. All right, let's look at the next problem. Find the amount applied to principal for the third month of a 4-year loan of $17,300, which charges 3% compounded monthly with monthly payments. All right, so to find the amount applied to principal, now let's go back to that previous problem. We wanted to find, in this problem, the amount of the payment, the interest payment, the applied to principal, and the balance. So you'll notice that on the amortization schedule is the only place where we can ever find the applied to principal. So this problem doesn't have an amortization schedule drawn out for us to fill out, but we still have to make one because that's the way that we can find the amount applied to principal for that third month. So since we just learned how to create an amortization schedule, I'm going to let you do that part. But I will show you what your answers should be so that you can check your answers and make sure that it went correctly. So here's what the amortization schedule would look like for the first 4 payments. We only need 3 payments here, but I went ahead and showed you 4. So the payment amount, $382.92, we would find using the Tvm Solver with $17,300 as our present value. It's a 4-year loan, so N would be 48, 4 times 12. Interest rate is 3%. Future value is 0, since we're trying to find the payment amount that would amortize the loan. And then it's compounded monthly with monthly payments, so payments per year, compounds per year, both 12. So that should give you $382.92. Then to find the interest amount, we take our balance, $17,300, times the interest rate, which is 3%, 0.03, times time. Now, here in the last problem, time was 1/2 because payments were being made semi-annually, so each payment got half the interest rate for the year. Now that we're making payments monthly, each payment will be charged 1/12 of the interest rate per year. So 17,300 times 0.03 times 1/12, that's going to give us the $43.25. We'll then subtract $382.92 minus $43.25. That's going to give us the amount applied to principal, $339.67. We'll then take our balance, $17,300, subtract out the $339.67. That'll give us the new balance, $16,960.33. And then we just repeat the process. So to get the $42.40 for that payment, we would take $16,960.33, the previous balance before payment number 2, times 3%, so times 0.03, times 1/12 for the time, because the second month is still 1/12 of a year, just like the first payment is. That would give us our $42.40. Subtract the amount from payment, or the interest amount from the amount of payment. That gives us our applied to principal. And then we just keep going. So we're looking in this problem for the amount applied to principal for the third month. So amount applied to principal for the third month should be $341.37. So we just have to repeat that process a couple times to get there. So it may not ask you for an amortization schedule on a problem, but if you're looking for an interest amount or if you're looking for an amount applied to principal, you need to create one. All right, let's go on to the next problem. All right, so often lottery winnings are divided into equal payments given annually for 20 to 25 years. So the present value of the winnings is worth less than the actual jackpot, depending on the rate at which the money could be invested. We want to find the present value using the given conditions. All right, I'll show you how to do the first part here with a jackpot of $4 million, interest rate of 7%, and 20 equal payments. And then I'll let you figure out the last 3 parts because they work very, very similarly. All right, so the first part, the first sentence of this actually tells us what we're going to do, and we're going to read it very literally. So often lottery winnings are divided into equal payments. So if you were to win $4 million in the lottery, which you won't because we learned about probability, they wouldn't give you $4 million. They would either give you 20 payments that add up to $4 million, or they would give you some amount of money that they have on hand right now, which could have been invested to pay out the $4 million. So that's what we're trying to find, is how much do they need to have on hand. If they want to pay you $4 million over 20 years, if they assume that their investment can make 7% interest, how much money do they need right now? All right, so let's grab our Tvm Solver. Let's go to Apps Finance Tvm Solver. Let's go ahead and zero out this to kind of reset it. Payment is at end, so we'll leave that there. All right, so for the first one, equal annual payments, there are 20 of them. So N is 20. Interest rate, 7%. Present value, that's what we're looking for. So it even tells us that. Find the present value. All right, so now the most common mistake I see here is to put the $4 million in the future value. So that would be, what payment do you need to make to save up to $4 million, which is very different than what this scenario is here. So instead, what the first sentence says, if we go back to our first sentence, lottery winnings are divided into equal payments. So we're going to take the lottery winnings and we're going to divide them into equal payments. So we really are going to do literally what it says. So it says equal payments. So that tells us where it's going. So $4 million divided into equal payments. So those payments, those equal payments, there's 20 of them. So we're going to divide it into 20 equal payments. So what we're finding is, if they were to pay out the $4 million over those 20 years, how much money would you get each year in that payment? And that's $200,000. So you get $200,000 a year for 20 years. The future value is 0. So you can kind of think of this as a reverse loan. If you were to win the lottery, which again, you won't, they essentially owe you money, and they're going to pay it off until they owe you nothing. So they're going to pay you off $200,000 a month for 20 years until they owe you nothing. Payments per year, compounds per year, both 1 because the payments are annual. So what we're solving for is, what is the present value? Essentially, how much do they need to have now to pay out $200,000 a year for 20 years at 7% interest? So we'll solve for that present value. And we get $2,118,802 and about 85 cents. So they don't need to have $4 million on hand to advertise a $4 million jackpot. They only need to have a little over $2 million on hand, because they could take that $2 million, invest it at 7%, and pay out $200,000 a year for 20 years, which would end up paying out $4 million. So, and this is actually how the lottery works. So if you were to win the lottery, you either take the present value, the smaller lump sum amount, or you can take the payments over the years. And so they give you the choice because it doesn't matter to them. They have that money, the present value right now. They could pay out of it over time, or they could just give you what they have in the present value right now. Same amount either way. All right, let's move on to the next one. All right, here we want to find the effective rate for a payday loan, which charges $66.03 for a 2-week loan of $430. All right, so the effective rate is the percent charged per year. So it's the percent change over the course of a year. In this case, we have the amount charged not over a year, but over 2 weeks. So we just need to convert that. So there's a couple different types of effective rate problems that you'll see. Some of them you're given a rate and a number of compoundings, and we can use the effective rate function when we're doing a problem like that. For a problem like this, we're just going to use very basic math. So what we're going to do, first we're going to find how much money would be charged for a year of this. So if you're charged $66.03 for 2 weeks, how much would you be charged for a full year? So $66.03. That's every 2 weeks, right? So if we wanted to, we could divide it by 2 to figure out how much you'd be charged per week and multiply by 52. Or a little more simply, how many 2-week periods are there in a year? And that's 26. So we can just multiply this by 26. So if you're charged $66.03 every 2 weeks, then for a year, to borrow that, you'd be charged $1,716.78. So now all we have to do is take that amount and divide that by the loan amount. So $430. So if you're paying $1,716.78 per year for a loan of $430, then what you're charged, and you have to be careful here, you might want to read this as 3.99% interest, but remember this is a decimal. That's actually 399% interest, 399.25% interest, in fact. And this is actually how payday loans work. They actually do charge 300, 400, 500% interest on their loans. It doesn't seem like a lot over 2 weeks, $66 for a loan of $430. But when you look at that over a year, then you notice 300, almost 400% interest. That's a lot of interest to be paid. So, all right, that's how we do that one. Let's go on to our last one. All right, we want to find out how long will it take for money to double if it's invested at 8% compounded monthly and 5.7% compounded continuously. All right, so these we have to work in two different ways. So monthly, anytime we have interest compounded a finite number of times, we use the Tvm Solver. And when we have interest compounded an infinite number of times, that's continuously, then we use our formula A equals P e to the RT. So let's solve the first part first, the compounded monthly. So we'll use our Tvm Solver for that. We want it to double, and it's compounded 8% monthly. All right, so let's get our Tvm Solver. So Apps Finance Tvm Solver. All right, let's zero these out again. All right, so it may be confusing what we're solving for here, but let's just put in what we know. Interest is 8%, so I is 8. There's no payments here, so payment is 0. Payments per year, compounds per year, 12, because interest is compounded monthly. Now it says we want the money to double, right? Now it doesn't actually matter how much money you use, so you can actually just choose. Because the amount of time required to turn $1 into $2 is the exact same amount of time to turn $1 million into $2 million. So it really doesn't matter. So you can choose any value you want. So I'm going to choose $2. So that needs to be a -2 in the present value, because if I want to get $4 at the end of the time period, that would be doubling my money. Then I need to invest $2 now. Okay, so you could have used $1 and $2, $2 and $4, $3 and $6. It doesn't matter, whatever values you feel like using. So notice that we filled in everything except N. N is the number of times interest is compounded, which can help us find time. It doesn't give us the number of years, but it can help us find the number of years. So let's solve for that. So we get 104.318, blah, blah, blah. So that's not 104 years. That's 104 times the interest is compounded. And interest is compounded once per month. So what that tells us is that N, in this case, is number of months. So what we can do is just take that number. We can actually just move our cursor all the way to the end and do divided by 12. And then press enter, and we see that it is 8.69, 2 decimal places, 8.69 years is how long it would take for something to double at any amount to double at 8% compounded monthly. All right. So now let's figure out the second part, how long it would take for something to double at 5.7 compounded continuously. So again, the formula we'll use here, A equals P e to the RT. Again, we can just choose whatever amounts of money we want. So I'm going to use $2 and $4 again. So A would be 4. That's the amount we would have after some amount of time. P would be 2. E to the 0.057 times T. Okay. All right, so just a couple steps here to solve. First thing is we'll divide by 2. So that's going to give us 2 equals e to the 0.057t. Make that look more like an e. And then, so that's the first step we have to do. We have to get e by itself before we do the next step of taking the natural log of both sides. So natural log of 2 equals natural log of e to the 0.057t. So then what we're going to get is natural log of 2 just equals 0.057t, because remember, natural log and e are inverse functions of one another. So what natural log does, e undoes. All right, so then we can just divide by 0.057. And we'll get, so we can do this in the calculator. Quit out of our Tvm solver. So 0.05, or sorry, natural log of 2 divided by that. So natural log of 2 divided by 0.057. And so what we get there is 12.16 years. So that's how long it would take to double at 5.7% interest, compounded continuously. As a reminder, don't use natural logs to solve for a or p. You can evaluate this thing in your calculator. E to the RT, you can evaluate that in your calculator. If you have p, then just multiply it times p to get a. If you have a and don't have p, then just divide both sides by whatever you get for e to the RT, and you solve for p. No need to use natural logs. The only time you need to use natural logs is if you're solving for r or t. If you're using it for anything else, you're not doing it correctly. All right. Those are the most asked about problems for this unit, so hopefully that helps. Good luck on your test.